So we're skipping a few chapters in our math book and jumping into chapter 10 on probability. And today's lesson is really just about identifying outcomes and events, which can become tricky for quite a number of you because you're so well trained at this point to tell the probability of a simple event. But that's what you try to do with this one, when all it's really asking you to tell is how many unique outcomes are there, or to name the outcomes that satisfy a certain condition. So with a new chapter comes new vocabulary, and so we have experiment. Most of you, I'm sure, understand this word quite well. It's just an investigation of a procedure that has varying results. We wouldn't conduct an experiment on something that we know the answer to all of the time. We use this word in this situation when we're trying to figure out the answer to something that can have many answers or multiple answers. These three words, outcomes, event, and favorable outcomes, are all very similar in what they mean, which makes them really hard to keep straight in our head. I think of this as kind of like least specific to most specific. So outcomes are all the possible results of an experiment. Whether it's likely or unlikely to happen, we don't care for outcomes. We just list it. It's any outcome that could be possible. An event is a specific kind of outcome. So if I have a bag of marbles, like we'll see later today, the outcomes would be the list of all the colored marbles that are in there. An event might be choosing a blue marble. So it's a specific outcome that we're looking for, maybe a specific set of outcomes. They might give you more than one. Favorable outcomes is more specific than the event, because now we're taking the event and we're saying the outcomes that are specific to that event, that satisfy that event. So that choosing a blue marble, the favorable outcomes would be the number. If there were two blue marbles, it would be blue, blue, because there are two blue marbles. So we talked about how those words look like an example. So to experiment, choosing a marble. The possible outcomes in your work, you'd actually list them: purple, blue, green, yellow, red, green. Everybody said, but you wrote green twice. Yes, because there are two green marbles. I have to list all of them. It's not how many unique colors are there. It's list everything you see. The event, choosing a green marble. The number of favorable outcomes out of this collection of outcomes is 2. And the list of those favorable outcomes is green, comma, green, because there are 2 green marbles, so I list each green marble separately. So we talked about the experiment, rolling the number cube. What are the possible outcomes? For some of you, that what are doesn't really tell you what to do, so I said, well, then change it to list. And the possible outcomes of rolling a number cube are it's not 6, not how many. The possible outcomes are 1, 2, 3, 4, 5, 6. Then they say, well, what are the favorable outcomes of rolling an even number? The answer's not 3, not that there are 3 even numbers, but which numbers are even? What outcomes are even? 2, 4, and 6. And what are the favorable outcomes of rolling a number greater than 5? The answer is just 6. The answer is not 1. Yes, there's only one outcome that is greater than 5, but they want you to name that outcome. 6. And if we talked about in class how if they said rolling at least 5, the answer would be 5, 6, because at least includes 5. So you're responsible for remembering your inequality language from earlier this year. Then you had to write this down in your notes, and you guys were super successful with this in class. You randomly choose a letter from a hat that contains the letters A through K. What are the possible outcomes? You list them all: A, B, C, D, E, F, G, H, I, J, K. Then they ask, well, what are the favorable outcomes of choosing a vowel? I was super pleased most of you did not say 3. You listed the 3 outcomes that were a vowel, which is what they're asking you to do: A, E, and I. We don't include O and U because they're not part of this set of letters in this hat. So we stop at I. Then we can also count the outcomes. So we have the spinner, that's the experiment. How many possible outcomes are there? I talked in class about how had this answer 6 not been there, most of you would have told me 4, because you would see green, red, purple, blue, and think, well, there's only 4 outcomes because there's only 4 colors. The color has nothing to do with it. Your brain is starting to get into probability when you do that. The outcomes are all the different ways this little arrow can land on this spinner, and there are 6 different sections that this arrow can land in the spinner. So it has 6 outcomes, and those outcomes would be purple, red, blue, red, green, red. So B, in how many ways, notice the language is switching and they want a number, can spinning red occur? 3 ways. And then I said, well, what if they said list the ways or name the ways? Well, you would have written red, 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 because there are 3 outcomes that are red. C is not tricky, except for if you're not reading, which some of you just decide not to do. It's not that you're not capable of reading, you just choose not to read the directions. And how many ways can spinning not purple occur? Which means how many options are there that are not purple? Well, there are 5 sections of the spinner that are not purple, so there's 5 ways, and then list them. Red, 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 green, and blue. The order doesn't matter when you write this list as long as you list them all. I could have said red, green, red, blue, red, or red, blue, red, green, red. It really doesn't matter. And the way to know if you've done it correctly is whatever number you put here, you should have that many names over here. And so you did this one, and I had you copy this down, and I said, well, just put the first letter in the marble for your notes. But how many possible outcomes are there in this experiment of randomly choosing a marble? There are 8. How many ways can choosing blue occur? 2, because there are 2 blue marbles. And this says, and how many ways can choosing not yellow occur? Well, I see 1, 2, 3, 4, 5 marbles that are not yellow, so we write them down. Blue, blue, red, purple, green. This was the order given to me by one student in class. As long as you have all 5 of these in any order, you're all set. Don't abbreviate. Don't try to write blue times 2 or blue squared. Write it all out, please, so that there's no chance for me to interpret what you're trying to communicate incorrectly. It's not a lot of work or a lot of writing, so I expect that you can do that. And just when you're doing your practice, really be cautious. Are they asking you for how many or to list the outcomes? Really pay attention to that language, because the language does impact the answer that you give. And that's our intro to probability.